1, 2, and 4. Any others? Okay. Let's start with this. Alright, for number 1, you needed to solve this. So distribute, so we have 6x plus 6 minus 3x. Then combine your like terms on the same side, the 6x and the negative 3x to get 3x. If you saw that these have the same things on both sides, you could have stopped there, said this is infinitely many solutions, or if you forgot that, you could have kept going. Let's say you got rid of the 3x and the 6, you would get 0 equals 0. Or if you just got rid of the 3x, you get 6 equals 6. Both cases, your variable disappeared. You have the same number equal to the same number, so this would be infinitely many solutions. Questions on that one? Then number 2 is similar to what we did on the last one, domain and range, furthest point to the left and right, lowest to highest. So if it helps you, I kind of draw in these lines to help me see left and right, lowest to highest. And I'm just going to write this in interval notation today. So furthest point to the left would be negative 3. Furthest point to the right would be 2. And then lowest to highest would be at negative 1 and 3. Questions on that one?
Is that a zero?
Oh, this is supposed to be a B. My handwriting is just not the greatest. It's worse. I don't know if that was better. Alright, and then number 4. Evaluate. This is in function notation, so this is saying this is your x. Put that value in for x. And simplify. So this would give us 2 times the square root of 16. The square root of 16 is 4. And 2 times 4 is 8. So the answer, how we would write it, is f of 9 equals 8. It's really saying when x is 9, y is 8. Questions on that one? Alright. Before we do notes and stuff like that, let's talk about the last test. Many of you finished, some of you did not. 1. If you did not finish your test, your name is on this board over here. Everyone look. Your name will stay there until you finish your test. Once you finish your test, I'll erase it. Also, we're going to do something new. You have until the next test to finish this test. Otherwise, you'll have to retake. I'll grade it as is, and you'll have to retake. Which means you need to come see me or Miss Larson as soon as possible, before school, after school. If we have time in class, use that time to get that test done as soon as possible. There are a lot of times at the end of these past 2 marking periods, we've had a lot of people who have not finished tests, and we don't want that to repeat into the 3rd marking period. So look at your course calendar. When is our next test? That's the quiz. 22nd. So you have from now until then to finish the Unified test. So a little less than a month. There are plenty days I am in the morning after school. I'm here all the time. So you have no excuses as to why that would not be finished by then. Questions on that? Okay. Right? Other things on the calendar. Next Friday is going to be your next flex day. However, that day is going to be the day you take the STAR test again. So I'll send out reminders so that you can bring your laptop. And then the second flex day will be like the last one where we may need to finish a little bit of notes. You'll have your review, or you can use that as a flex day as well. And then the quiz and then the test. And then take note of all your Khan Academy quiz dates as well. If you forget any of these dates, where else can you find them? Canvas? Where else? Usually on this board or on that board. This one only the week up until, that one the entire month. This on Canvas, the announcements. So you have plenty of ways to see these dates, know when these dates are, so there aren't any excuses as to why you're not getting this stuff done. Questions on any of that? Okay. We'll briefly start this, but not really. So the next unit we're doing is kind of different than the things we have been doing in the past, because now we're leaning more towards factoring. We're going to get into quadratics and things like that. We'll just do these three. If we don't have time to finish all three, that's fine. So this is a good practice to see like what we'll be doing / undoing. So if I wanted to solve this, I would distribute, multiplying whatever's outside to whatever's inside. When you multiply variables together, you may or may not remember this from algebra, your exponent rules. These both, the variables, have exponents of 1. So when you multiply them together, you're adding the exponents. So this would become 3a squared, because they're adding 1 and 1, and then 7a. So if we were multiplying this next one, negative 2m to everything, what would that be? Multiply the numbers first. When you're multiplying the variables together, you're adding the exponents. Anytime you don't see an exponent, it's 1.
Negative 2 to the third power,
Right.
Plus 12 and 1. Oh no, 2. Or the positive.
M to the what? It's the end bit. You're multiplying to the second power. And then the last one would just be plus 2m. This next one's a little tricky because it has 2 variables, but not both variables are there. When we multiply those, what would that be? Aren't numbers, so the 4 is going to stay the same. The y is going to stay the same because there's only x's, but what would that new exponent for x be? Minus. Same thing, multiply your numbers. Your x is just going to stay the same, multiply your y's.
Two y to plus 5 in the second time.
Not 2. And then x to the third stays the same. Y to the second power is 3. Right? The reason we're doing this is because what we're about to do, factoring, you may remember it from Algebra 1, is we're going to be given things like this, and we're going to put it in this format. So when we get back from lunch, we'll start that process. This definition and this example, I'll read it out loud so you have it as well. It says separating a polynomial, which is an expression that has variables and exponents in it, back into a product. And then the simplest form is 4a squared plus 8a. The factored form is 4a, then in parentheses, a plus 2. Right, so I'm going to kind of talk through this process before we actually do examples, and then we'll start the examples. So, when you factor, and you may or may not remember this from algebra, you are looking for the highest number you can divide out of both of them. Some of these, factor-wise, you may know off the top of your head. Some of them you may not. So I would suggest, if you're not sure, maybe make a list off to the side. Let's actually do this in this space right here. So what are some factors of 4? What times what gives us 4?
4.
And 4 and 1. And
2.
2. Okay, for 8, factors of 8.
4 and 2.
4 and 2.
8 and 1.
Not 4 and 4. 8 and 1. And then writing them backwards wouldn't really change anything. Those are still going to be the factors. Okay, so find the highest number that they share. So they both have a 1, they both have a 2, but they both have 4, and that is the highest out of both of them. So what we do with that number is take what's given and start dividing. But we don't really, we divide, but it doesn't go away. It's weird. Because then we take that number we divided by and we put it outside of parentheses, so we don't actually want it to go away. We're just saying we divided by 4, and that's our factor. It's weird. Right? And then for each piece, you're dividing by 4 and seeing what numbers are left. So 4 divided by 4 is 1. 8 divided by 4 is 2. Then looking at your variables, you're looking at the lowest exponent in your variables. So this one has a 2, this one has a 1. And you're trying to figure out, do they have variables in common? Yes, they both have a's. And how many a's could I divide them both by? So I can't divide this one by 2 because it only has 1. But I could divide them both by 1a, which is why that a is on the outside of these parentheses. And then you see what's left. So when you do this, the exponents are really subtracting. So it would be 2 minus 1 gives us 1a. These a's would cancel, so there's no a for that second one. So when you do this, the inside parentheses, you want that to be prime. That means you can't factor anything else out except 1, but that wouldn't change anything. Or its only factors are 1 and an 8. That's our goal. To get out anything they have in common, and then make sure the inside is prime. Okay. I know this will make more sense once we actually get into the examples, but what questions do we have right now? Brian?
Was that under the plus sign?
It was a 1. Exponent of 1. Any other questions?
I screwed up a little bit.
Yeah, so at 26. And then I'll look at the student chart. Alright, so let's do some examples. So through the steps, we're going to find the GCF, the greatest common factor, for all the numbers. See if there are any variables they have in common. If there are, we're going to look at how many variables we can divide out, divide them all out, and then write it a certain way. So let's start with 1. Sometimes the lowest number you see is the highest number we can divide out. That's not all the time, but sometimes. So if we're thinking about our factors of 3, our factors of 12, I'm not going to list them out, but you can if you want. What is the highest number I can divide out of both of those things? 3. So I'm going to do this for a little bit and then kind of drop this process. You can continue to do this if it helps you see it, what you're doing. We would divide both by 3. Can we divide both by an x? No, because only one has an x. So we would put that 3 that we're dividing by in front of parentheses, or outside of parentheses, whatever. And then we're looking at what's left. So 3x divided by 3. 1x for this x. And then 12 divided by 3. 4. So plus 4. So our inside is prime. It doesn't have anything in common. If you wanted to double check yourself, you could multiply it back out. 3 times x is 3x. 3 times 4 is 12. So we get the original, so we know that works. Questions on that so far? Let's try the second one. Highest number we can divide out of both? 7. If we're dividing them both by 7, 7's going to come out in front of parentheses. What would be left inside 1? Y minus 1. Multiply it back out. 7y minus 7. That works. For 3, you may know all the factors of 8, 36. There's a lot, so you may not remember. So let's list those out. 8 we said was 1 and 8, 2 and 4, 36. And if you're not sure, you could do this. And I kind of did this already. Whatever number you get, start dividing. All of them are divisible by 1, so 1 will be a factor. It's a process, but you could start dividing it by 2. It's even. It should give you a whole number. Divide it by 3. See if you get a whole number. Keep doing that until you don't get a whole number. So like 5 is not a factor. So if you weren't sure about the factors, that is a way to do that. Okay, so we have 1 and 36, 2 and 18, 3 and 12, 4 and 9. Are there any others? Six and 6. If you're doing that dividing process, once you get to the same number, you're done. There aren't any. If you get to something like 4 and 9, you could try the numbers in between. If none of them give you a whole number, there probably aren't any. There aren't any. Let me rephrase that. Right? So highest number that you can divide out of both. 4. Right? So if the table kind of helps you, or the chart, whatever the factor chart helps you see it, you can do that. Can we divide out any variables? No, because they're not the same. One has m, one has n. If they both had an m or both had an n, then we could. I'm going to stop writing that we're dividing, but feel free to continue to do that. So if we're dividing both of these by 4, what would be left? 2m plus especially when you have multiple variables, redistribute it back out, see did you get the original or not. And if we did that, this would be 8m plus 36n, so that works. Questions so far? What would the highest number we can divide out of 4 be? 5. Any variables we can divide out? No. And then if we divide both of these by 5, what's left? X plus 6y. Okay. And then move on to the next page. Wow. We're going to jump around here. Let's start with 6. Highest number we can divide out of both. 4. Can we divide out any y's? Yes, and how many?
2.
Can we take 2 y's out of this one?
1.
1. So just 1. And if we're dividing both by 4y, remember dividing out variables, you're subtracting the exponents. This one has a 1. What would our new inside be? One y. Minus 6. Now what? This 6. Because the y's would have canceled each other out since they're both have an exponent of 1. Questions on that?
So remember, when you're going through exponents, when you're multiplying, it adds to the exponent. So you're not multiplying the exponent, adding to it.
And then dividing would be opposite. Dividing, subtract, multiply, add. Okay, let's do 8. Highest number we can divide out of both. Elijah said that louder. 2. Sometimes the highest number isn't very high at all. Right. Are there any variables we can take out of both? H. So if we divide 2h from both of those things, what's left? 7g. Not 6. 9. Minus 9. Okay, let's do 9. Highest number we can divide out of both. 15. Right. I'm going to show you what happens if you don't choose the highest number. So we know it's 15. I'm going to write that off to the side. Let's say instead we saw that we could divide both by 5 or by 3, either or, it doesn't matter. I know that's not my highest, but let's say I forgot about 15. Right? We'll come back to that. Can we take out any variables or divide by any variables? 1b. What about a? Can you take out any a's? Do they have a in common?
Take out
1a and 1b. If we do that, what would be left on the inside?
3a.
Minus.
6.
If you divide by not the highest number, or is not necessarily the wrong number, just not the highest, you'll see that this is not prime. because these have something in common that you can take out again. So you'd have to just do that one more time. I can divide these both by 3. So I would take that out and move it to the front. And then simplify. So if you have to take something out, that means you probably didn't choose the highest number to begin with, which is fine, as long as you get there eventually. So whether you do that first or you eventually do it does not matter, as long as you get there eventually. Okay, so 15AB times A minus 2 would be our final answer. Do we have any questions on that one? Let's do 11. What did those have in common? A. Sometimes you won't have variables or numbers, coefficients. There we go. So we could take out or divide an A out of both. What would be left? B minus, not 0, 1. Right, think about it like 1 over 1, x over x, it would give us 1. Right? So that would be its factor form. For 13, is there anything we can divide out of those? Five and 13 are prime on their own. X and y are different. So because there's nothing besides 1, this would just be prime. You wouldn't put 1 and then 5x minus 13y, because that would be the same thing. Let's do 14. Highest number we can divide out of everything. Can we divide out variables? Which ones? How many? Not 9, but you're close. Again, if you're not sure about your factors, put them off to the side. Start listing out all of your factors of 18, of 48. Find your highest. It is 6. Can we take out any variables? Yes. Which ones and how many of each? One A, 1B, and 2 C's, correct. Okay. If we're dividing out 6ABC squared of both of these, take your time, what would be left inside?
3A minus.
Yep, minus. So, doing that over here, just in case you missed y. $18 divided by 6 gave us 3. There was 2 A's here. One of them came out, so 1 was left. The B squareds completely went away. I'm going to put C squared here. And then the C squared completely went away. So the only thing left there was 3A. Then for the second one, negative 48 over 6 was negative 8. The A's canceled. The B's canceled. Sorry, that should have been 3. And then there was one more C than we divided out, so 1 C was left. So if the dividing piece helps you cancel stuff out, see what's left, do that. If you can see it without, you don't need to do that. Questions on that one? Move on to 15. Highest number we can divide out of all of them? 2. Can we take out any variables? Yes. Which ones and how many of each?
Next.
1x and 1y. If we do that, what's left?
One.
1x minus
Minus 1y.
1y plus
Plus what x?
the x's would cancel here.
Oh.
Y. So y's would also cancel here.
2 just y. Oh.
So the inside is still prime. Nothing is the same. We could only take one. The only thing they have in common is still 1. Let's do 18. Again, if you need to, list out your factors off to the side. Find the highest.
6.
It is also 6, yes. And then can we take out any variables? Which ones and how many of each?
2a, big B.
2a is correct, yes, and 2b is also correct. I'm repeating whatever you're saying. It's really a squared, b squared, but we all understand that that's what we meant. Again, take your time, divide each piece. What would be left?
2.
Remember, you're subtracting the exponents.
A cubed
A cubed, or a to the third, yep.
minus
There would be one b left. There'd also be some a's.
2a
A squared.
minus 1.
Minus 1. Yep. So that looks like it should be simplified more, but even though these two I could divide out of 2, I can't do that to the 1. These two have an A, this one doesn't. This one has a B, nothing else does, so it is in its simplest form, or factored form. Okay, questions on that one? Let's do 21 and then 24 and then any others you guys want to see, and then you'll have time to practice. Okay, so for 21, what could we factor out of that?
21.
Mm-hmm.
1m
1m
and 1n.
and 1n. What would be left?
M squared
M squared minus
minus 1 and n.
mn plus 5n squared. There we go. Again, it looks like we should take something else out, but only 2 of these have m's, 2 of them have n's, 1 has a 5. So that is in its simplest form. You could distribute it back out, you should get the same thing. Okay. Questions on that one? Last one, 24. So I'm going to write this out because there's a lot of variables, a lot of numbers, just so we see what all is happening. What is the highest number we can divide out of all of these?
3
3.
a b squared c.
A was right, B squared was right, and you said 1, yes. So if we're dividing that out of everything, do this part, but if it helps you see it, you're welcome to do that. What would be left?
1a squared
Minus.
c.
Because each of these has one more than the denominator, so there would be one more left. And then plus. Will we still have an A?
No, I
3.
C squared, yep.
C.
C squared, yep. So we'll rewrite that because it looks messy. 3abc squared times a squared minus 3abc plus 5a squared c squared. Was a lot. But you guys did that. Good job. On this page, on the last page, do we have any questions we want to see, go over, any questions about? On this page?
Yeah.
Okay. Any others? So let's do those three. If you have others, we'll come back to those. So starting with 16. Highest number we can divide out of all three of these. 9. You were close because 9 and 18, but the 24 can't divide that by 9. Close again because 18 and 24 would divide by 6, but 9 wouldn't. 3. Right. Can we divide out any variables? Which ones and how many? This one. R. Yep. No S's because this one doesn't have any. So we divide each piece by 3R. What's left?
R 7.
R to the 7, correct? Minus.
6. R.
Correct. Minus. 8. S squared. Correct. Questions on that one? For 19, highest number we can divide out of each? 14. Can we divide out any variables?
H.
And what would be left?
1.
GH
Plus 2G.
plus 2G
Plus 1.
plus 1. Questions on that one? Okay. And then 20, highest number we can divide out of each. Six. 3 would have worked if you did it and then you would have had to still divide out. The 6 is the highest. Right? Which variables can we take out? Z, just one. Can we take an X out of this last one?
No.
y out of the middle one. So just z. Okay. And then what would be left? 3x squared. Missing one thing from that one. Y. There we go. Minus 4 x plus 6y. And how many z's? Z's. Any other questions on these? So what I would suggest is there is one Khan Academy on this that is due next Friday. If you were paying attention, you got this. It should take no more than 5 minutes. Do it right now so you don't have to worry about it next week, so it's done and out the way. And then practice on the back page on the ones we didn't do. Then after you've done at least the Khan Academy, if you need to finish your tests, want to work on retake stuff, you could easily get that stuff done next week, and retest next week if you do the test corrections, Delta Math Khan Academy. Also remember that the Delta Math Khan Academy you can do on your own, but come see us if you need help, want us to check over things like that. Test corrections need to be done with us though, unless you have them written down. Right? Questions on what you're working on for the remainder of class? Use this time wisely.